Welcome to this video. I've got a lot of stuff I want to cover today, so I'm going to get straight into it. My name is Jason Morrell, and I've received lots of questions, different types of questions, but all based around the if function in Excel. So I thought I'd round them all up and knock this bad boy off the list. Here's what I'm going to cover. I'm going to start with a very quick recap of how to do a simple if formula. I'm then going to introduce multiple criteria using the AND and the OR functions, both individually and collectively. I'm going to use a mixture of text and number examples, just to give you some variety. I'm also going to show you how to use symbols in your if formulas. Then I'll go a little bit deeper, and I'm going to cover multi-level if formulas. And I'm going to do this in three ways. I'm going to use the if function, I'm going to use the ifs function, and also the switch function. And to finish off with, I'm going to show you how to compare two different lists, list 1 versus list 2, to check whether items in the first list exist in the second list. And to get that done, I'm going to use a combination of IFERROR and VLOOKUP functions. Here's our first table. It shows a number of tradesmen, so it has their name, what their trade is, where they're based, their age, their hourly rate, the number of hours worked, and the number of jobs completed. I'm going to use a variety of this data and create a number of if functions, which get increasingly more complex as we go through, to either retrieve or calculate data within the table. So we're going to start with this one here. In this first example, we're going to create a very simple if formula just to identify any brickies in the list. So I'm going to come down here. And the basic premise behind an if is that you test one thing, and you ask the question in such a way that it only has a yes or no answer, or as Excel puts it, a true or false answer. So you have your test. If it's true, you do this, but if it's false, you do that. So our formula here is going to start with equals if, open the brackets. We're going to test whether the trade on this particular row is equal to bricky. Because it's a text item, I put it within quotation marks. But in order to make it a little bit more flexible, I've actually got the word bricky at the top here. And as we go through, I'm going to refer to this data at the top to make the formulas more dynamic. So if we ever want to change the results afterwards, we can change the trade to something else and get a different result coming back. So let's remove this and instead refer to J1. And I'm going to fix that cell reference because in a second, we're going to copy this formula down for the rest of the list. So is the trade on this particular row equal to the trade we're checking at the top? It's either yes or no, true or false. If it's true, I want to put a simple marker, like an asterisk. If it's false, I'm going to display nothing. So quote, quote will display nothing. Close the brackets and enter. Now the first one is a bricky, so it comes up with an asterisk. But as we copy this down, you'll see a mixture of asterisks where they're brickies and nothing if they're not a bricky. And that's a very simple if formula here. One test, C6 equals J1. If that's true, if they're the same thing, display an asterisk, otherwise don't. Now, you can introduce a number of different things within the if formula. In this next example, I'm going to create an if formula to identify any bricky based in Queensland who's completed more than 20 jobs. Now to do this, we need to use an AND function. So all of these things must be true. Therefore, this and this and this must be true. So you can either create the AND function first and put it within an if, or if you know what you're doing, you can actually just start with the if and put the AND as the logical test within that if function. That's what I'm going to do here. So I'm going to start with equals if, open the brackets, introduce the and open the AND brackets, and then test my first thing. So firstly, is this cell here equal to this cell here, which is the trade we're checking for? And I'm going to fix that cell reference at the top because it needs to be the same all the way down this column. That's my first test. The second test is, are they based in Queensland? So I'm going to click this cell here within the table and say, is it equal to this state that I'm checking at the top? I'm going to fix the cell reference there, comma. And my third test is, did they have more than 20 jobs? So the jobs here, is it greater than this value at the top, which I've set, fix the cell reference, and close the brackets for the AND function. So the AND function is testing three things, all of which must be true to be flagged in this column. So if that whole thing is true, show a marker, like an asterisk. Otherwise, show nothing. And we're then going to copy this down. And there are two people in the list that meet all three of those criteria. My next example goes another level deeper again. So what it's asking for here is to identify any bricky or plasterer in the list who resides in Queensland. So there's actually an and an or element there. So they've got to reside in Queensland and be one of these two trades. And to identify whether they're one of those two trades, it's this or this. Okay, so let's write this out. I'm going to start with equals if, open brackets, introduce the and, open the brackets again. And the first test within the and is testing the state in the row to see is it equal to the state at the top. And I'm going to fix that cell so it works for the whole column. Then I put a comma. And the next thing I put in is the OR function, which says, is the trade on this row equal to the trade at the top? Fix the cell, comma. So it's saying, is it this or is it this next bit? So I test the trade cell again and say, is it equal to the second trade at the top? And again, I'm going to fix the cell for consistency. close the brackets for the OR, and close the brackets for the AND. So we're now back inside the if function. So that whole AND and OR combined statement is my logical test. If that's true, show the marker. If it's false, don't show anything. So close the brackets, and let's copy this down. Now, instead of just showing a marker, I could actually do a calculation here instead. So instead of the asterisk, I'm going to replace that with an income calculation. And for the income, I'm just going to multiply the hourly rate by the hours worked, but only for those people that are currently marked with an asterisk. So I've deleted the asterisk. I'm then going to say, take this hourly rate and multiply by this hours worked. So both of those details are on the current row, so they don't need fixing. Otherwise, leave it as blank. So now what happens is, you get your figures where there was previously an asterisk, but that figure is actually a calculation doing stuff with something within the table there. And of course, after this, you can just reformat to dollars and cents. In this last example, I want to identify anybody who had less than 20 jobs or more than 70 jobs. So I'm trying to pick out the people at either end of the spectrum that are either really low or really high. I could achieve this using a standard OR function, but what I want to do is just introduce a very simple multi-level if function. So I'm going to first of all test for one thing, and if it's true, do whatever. But if it's not true, I want to introduce a second if function to test something else. So it goes like this. Equals if, open the brackets. Let's first of all test whether the number of jobs is less than 20 for the current row. So this cell here, is that less than, I'm going to refer to the cell at the top there and fix it. If that's true, let's maybe put an L for low, comma. So otherwise, and here we're going to introduce that second test. So we put a second if function in, open the brackets for that. And our second test is checking the same cell for the number of jobs. Is it greater than the maximum figure at the top here? And again, I'm going to fix that for consistency. So that's my second test. And if that's true, I want to show H for high. Otherwise, show nothing and close off your brackets. Now there's two closing brackets there because there's an inner function and an outer function. If you ever get confused about the brackets, they're all color-coded. So the outer set is always black, the next inner set is always red, and then every further inner set has a different color. So that there will do the job. And for those outside the ranges, so less than 20 or greater than 70, you will see L or H against each of those. Now, instead of letters, what you could put here instead is different symbols. Now, symbols are just characters from a character set, and you get to it by going to the Insert tab at the top here and choosing symbols. So what I'm going to do is just put a couple of symbols in these two cells here, and then refer to them from my if formula. So in that first cell then, I'm going to go to Insert, choose Symbols, and Symbol again. There's lots of fonts that have different symbols. So you could, for example, go to Wingdings down at the end there. So it's Wingdings, Wingdings 2, and Wingdings 3. And these have lots of different symbols you could use. So you could use any of these in your spreadsheet. You can also go to the Arial. So the standard Arial font there has a number of symbols. And if you go to the subset here, you can choose things like geometric shapes. You could choose things like arrows or box drawings or this kind of stuff. And it takes you to the appropriate place in the character set. And, again, there's some quite useful little symbols you may want to use here. So let's maybe use these two here, the up arrow and the down arrow. A lot of people use the happy faces and things like that. It's entirely up to you what you use here. So I'm going to start with the up arrow and insert that. Close. I'm then going to go to the next cell, do an insert symbol again, and just insert the down arrow in that cell. So now, in my if formula, rather than referring to L, I'm going to refer to the cell that has the down arrow. Fix the cell reference, that's that bit done. And instead of referring to H, I'm going to delete that and refer to the cell that has the up arrow, and again, fix it. And if we copy this down, we have a number of up and down arrows in our list. Now, if you want to color code them, so maybe you want the up arrows to be blue and the down arrows to be red, or something of that nature, you just use conditional formatting. So very simply, we can take this whole range here, and on the Home tab, set up two conditional rules. So firstly, we're going to go conditional formatting, new rule, and format only cells that contain. Down in the rule here, we're going to say cell value is equal to, and in the cell reference there, we're going to pick the up arrow to start with. And down on the formatting, we click the Format tab, we go to the font, we set the font color. Because this is an up arrow, maybe it's a blue arrow. And click OK. That's the first conditional format done, and you can see the up arrows are now blue. If we do the same thing for the down arrows, we go back to conditional formatting, we choose new rule, formats only cells that contain, and again set up a second rule that says the cell value is equal to, and in this box here, refer to the down arrow cell, and set the format. So let's change the font color to red, and click OK. So now you've got a number of colored up and down arrows, indicating those that are sort of really low on the range or really high on the range. So there's all sorts of things you can do here. Now let's take it up another level. Okay, here's a different example. Over here, we have a simple table showing what scores contribute to what grades. So if you score above 80, you get a grade A. anything between 70 and 80, you get a grade B, and so on. Here's a bunch of student scores, and we're just going to create a multiple level if function to work out which grade each student has scored. So let's start with the first one here. So in this first cell here, I'm going to introduce the first if, which says, is the student score greater than the first score grade? Fix the cell reference, because it needs to refer to the same cell all the way down this column. If that's true, then the grade is this cell here, which again I'm going to fix. If it's not true, it does the next test. So the next test is the student score greater than the next score grade? Fix the cell reference. If it is, the grade is B3, fixed. If that's not true, we introduce the next test, which is the score greater than the next score grade? Fix the cell reference. If it is, the grade is this, fixed. Otherwise, next test. And you get the idea. So we're just going to go through and complete this for the remaining grades. This test is saying, is the student score greater than this cell here? Fixed. If that's true, the grade is this, fixed. If not, do the next test, which is the student score greater than the 40 cell? Fixed. If it is, the grade is grade E, fixed. Otherwise, it's a fail. And I'm going to fix that cell reference. Because it's the last test, we have all three parts completed. And all we've got to do here is to close all the brackets for the nested functions. Now there's 5 tests, 5 closing brackets. The last bracket is always black, don't forget that. So I'm going to press enter. Now the first one is grade C, because our test was, is the score greater than 70? If we want to include 70, we'd have to make the test greater than or equal to 70. Anyway, as we copy these down, each of these scores has an appropriate grade, including the 2 fails down here because they were below 40. Let's do a slightly more complex example. So this table shows the individual income tax rates for Australians 2017 to 2018 tax year. So the first bracket says if you earn up to 18,200, you actually pay no tax. If you earn between 18 and 37,000, you pay 19% of anything over 18,200. So this tax threshold bracket. If you earn between 37 and 87,000, you pay this much plus 32.5% of the difference. So anything over 37,000 up to the income you earn, that's taxed at 32.5%. So to simplify things, I've written the threshold figure here. I've written the base amount tax that you pay plus the tax rate you pay on the difference. So here we have a few sample incomes. I'm going to show you how to do this 2 ways. The first way is to use that multiple if approach again. The second is to use the ifs function. Now ifs is a reasonably new function to Excel, and it allows you to do multiple if functions, but in a slightly different way. So let's do this first approach. Now first up, we say equals if, open the brackets, and we're going to test this income to see is it less than the 18,000 threshold figure here. I need to fix that cell because every cell in this column needs to refer to that. Now if that's true, I'm just going to put the income as a straightforward 0 here. I'm not going to bother with a formula at this point. For the rest, I will. If that's not true, as in they earn 18,000 or more, I run to the next test, which is if, and then we test the income here to see is it less than 37,000. Actually, I need to fix that cell first. But if that's true, the tax that you pay is this amount, which is actually 0 at the moment, but it might well change in the future. So it's that amount, fixed, plus this percentage, fixed, multiplied by the difference. So that is the income that you earn minus the threshold of the one above. And that cell also needs to be fixed. So anytime you refer to a cell in this table, it needs to be fixed. Anytime you refer to the income cell, it doesn't need to be fixed. So this little calculation here, the base amount plus the percentage rate of the difference, that's the formula we're using here. Now, if that's not true, as in they earn more than 37,000, we move on to the next test. So if, again, we test the income to see is it less than 87,000. Don't forget to fix it. If that's true, then the amount of tax you pay is this figure here, fixed, plus the percentage rate, fixed, multiplied by the difference. So that's the income minus the threshold of the previous bracket, fixed. If that's not true, we move on to the next test again. Just 2 more to go. So we say, is this income here less than 180,000? It's a lot of money, fixed. If it is, then the income tax that you pay is this amount, fixed, plus the interest rate, fixed, multiplied by the difference. The difference being the income minus the threshold. So that's where we're up to. Because there's only one more tax bracket, it just says anything over 180,000, you pay this. So that can be our false part of this last test. So I'll put a comma, and the amount of tax you pay if you're earning over 180,000 is this amount, fixed, plus the percentage rate, fixed, times the difference. And then, of course, you've got to close all your brackets, go back until you see the black one there, and you press enter. Now, all of these figures here are the tax that you pay based on these incomes here. So if I just change one of these to say 35,000, okay, the amount of tax that you pay goes to this. Now, if I choose an amount that's right on a tax bracket, let's say 37,000, then the amount of tax you pay is 3572, which as you can see is this here. So anything above 37,000, you pay this base figure plus 32.5% of anything above that figure. So that's the first approach, using multiple if statements. Now, using this new function called ifs, this lets you set like a hierarchy of tests or conditions, and as soon as one condition is met, it applies that value and stops. If it's not met, it moves on to the next test. So rather than nesting, all of these things are actually listed in sequence. It goes a bit like this. If I just do the equals ifs, open bracket, and click the fx at the top here, you can see the description here. So it checks whether one or more conditions are met and returns the value corresponding to the first true condition. So as soon as one is met, it stops, otherwise it continues on. Now, your logical test can be anything. If it's true, it does this. If it's not true, it brings in logical test 2. Okay, and it just pairs up with all the different things you want to test as you go through. So if I just write this out, I'm going to say equals ifs, open bracket. My first logical test is the income here less than 18,200, first threshold? I'm going to fix that cell reference. If it is, then my income tax is 0. If it isn't, I move on to logical test 2, which is the income less than the next threshold? Don't forget to fix it. If that's true, then the value is this amount here plus this interest rate here, fixed, multiplied by the difference. Same formulas as before, but we're constructing it in a different way. Now, if that's not true, then we move on to logical test 3, which is our income less than the next threshold? Now, I'm not going to go through every single one for this second example. I'll stop after this one. But we say H3 less than D5, fix the D5. If that's true, we'll work out for the income for this one, which is this value here, fixed, added on to the percentage, fixed, times the difference. So H3 minus the previous tax threshold. Press the F4 key, close the bracket. Now, there's only one closing bracket to go, because ifs is like the outer function for all of these things. And if you look inside closely, each set is paired up. So we've got one pair there. First test, if it's true, it does that. The next test, if it's true, it does this. Otherwise, the next test, if that's true, it does this. Okay, and it just keeps on going for as many things as you want to test. It provides a simpler structure than doing multiple if statements. Press enter, make sure this works. And again, we get the same results here. Because we didn't complete the formula for the last two brackets, it's just got NA here. But what you could do instead is, after that last test, you could just do a simple thing that says the rest. So, for example, is the income greater than 87,000? Fixed. And if that's true, just put whatever. The rest. So you can always create a catch-all if you want to, but you've got to have a separate test for it and catch-all result. So that's multiple if functions and the ifs function. Both achieve the same thing, but using different techniques. I want to finish by showing you how to compare two lists to see if items that appear in the first list exist in the second list. This is quite a common thing that people need to check. It quite often goes with things like VLOOKUPs. People often do VLOOKUPs, but they don't know how to compare two lists against each other. So just to explain what's happening here, this third table here just shows a number of product codes and a product description. This is like the reference table. In each of these tables, for list A and list B, we've put the product codes down here, and there are VLOOKUP functions here, which retrieve the product description from this reference table. So that's what's happening here. We've got one list of products for list A, and a different list of products for list B. And what we want to do is to say, look, is this product here, does that exist in list B? If so, show me something here. If it doesn't, show something else. So we're going to use what's called IFERROR in combination with a VLOOKUP. Here's how that works. Before I create the formulas here, I'm going to name a couple of ranges here. So I'm going to take this list of product codes in list A and just name that range list A. I'm going to do the same for product B. So take the product codes there, call it list B, and I'm going to refer to each of those in the VLOOKUPs. So in this cell here, I say equals VLOOKUP, open the brackets. My lookup value is the code that I'm checking. I'm checking it against the range that I've called list B. I'm returning the value in column 1, it's only a one column range or table, and I'm doing a false or an exact lookup. So that's the formula. Press enter. Now the NAs here mean that there's no corresponding match in the second table. Where it's showing a product code, it means it does exist over here. There is a match in the second table. So what we do from here is we take the existing VLOOKUP formula and prefix it with IFERROR and open the brackets. Now all the IFERROR does is it says check a value or check the output or outcome of a formula, and if it returns an error, any kind of error at all, display something in its place. So instead of displaying #NA, show something else. So what I'm going to do here is to say, comma, quote, quote, as in display nothing. And that just cleans up the list there. Let's quickly do the same in list B. So in the first cell here, I'm going to say IFERROR, open the brackets, do my VLOOKUP, where I look up this product code within the range I've called list A, and I'm just pressing F3 to get that pop-up list displayed. Return the value in column 1, and do a false lookup, an exact match. So of course, at the end of that, I've got to put what happens if it's false, because I've introduced the if error already. And that just clears up anything in the list that doesn't have a match. So the blank cells here tell you that there's no match in the other list. Where there's a product code returned, it says there is a match in the other list. If we want to reverse that, we actually just need to wrap this whole thing within a regular if function, which then controls the output. So if I put if open brackets at the beginning, if I check the result of this whole if error VLOOKUP combination and say, is it equal to quote quote, as in, is the result blank? If it is, put something like no match. Otherwise, if there is a result coming back, make that a blank instead. So what I'm actually doing here is to reverse the situation. And what you get is this, the no match, where it doesn't find a match in the other table, but blanks for everything else. So you can work it either way, just got to work with the logic. In addition to if error, which is like a catch-all for any type of error that may come up, you can also specifically say if NA. That's actually a dedicated function you could use if you wanted to. There's also a whole bunch of is functions. So if you want to test is blank, is error, is even, is odd, is NA, is not text, is a number. All of these kind of things can be checked. So once you've done the main formula, you can check any of these to see if they're true, and then take appropriate action. I'm going to finish off this video today by talking about the switch function. Now this is brand new for Excel 2016, so it's only just come out, and it really replaces or improves on the old choose function. So what I want to do in this last sheet is just to show you both of those as a comparison. If you've never used choose before, you might be interested to see how that works. If you have used choose before, you might be familiar with some of the shortfalls, and therefore switch might be a good function for you to start using. Now over here we have a simple table showing the number of points scored in a motor race depending on what position you get. So if you end up first, you win the race, you get 25 points. If you finish second, you get 18 points. Third place gets 15 points, all the way down to 10th place here, which gets 1 point. If you finish the race in 11th place or lower, that's 0 points. So let's do this first of all using a choose function. So we start here with equals choose. Open the brackets, and the first thing it asks for is the index number. This is the number or the cell that you're checking. So we're going to click this cell next door here, which contains the position of each of these 20 drivers. This one is the position for driver 1. That's what we're checking for. Now based on that value, which could be anything from 1 through to 20, we assign each value a result. So down here in the formula where it says value 1, value 2, value 3, and so on, it's basically saying if the position is 1, what do we want to see? If the position is 2, what do we want to see? And all the way through for as many as we want to put in. So for position 1, that's worth 25 points, so I could either type that in as a fixed value, or, because we have the table over here, I can refer to the cell here and make sure I fix it. Because when I copy the formula down, of course, I want every formula to point to B3. It moves on then to value 2. So how many points are scored if you end up in position 2? Well, that's this cell here, and again, I'm going to fix it. So I do this all the way down, and with a little video editing magic, I end up here. So let's just take a quick look through it again. We start with E3, that's the value that we're checking, the position of the racing driver in the race. Each of these subsequent cell references refers to the number of points for position 1, position 2, position 3, all the way down to position 10. When we press enter and copy this formula down, we get points totals for all of those drivers that finished in positions 1 through to 10, but anybody who finished 11 and below has a hash value, because there's nothing in the formula to cater for them, and there's nothing you can put in the formula to cater for them, unless you put the choose inside an if function, or an if error function. So that's the choose function. Let's now compare that against this brand new switch function, which goes like this. We start by typing equals switch. Open the brackets. Now the expression is the cell that contains the value we're checking, which again is E3. What follows is a pairing. So it says value 1 and result 1. And then further down it says value 2, result 2, value 3, result 3. So everything from this point forward is paired up. And what you're doing is you're checking a value and then saying what you want to see if that value is true. So the value is what you're checking this cell for. First up we say 1, as in if this driver finished in position 1, he's going to score how many points. So we come across here again and click B3 and fix it. So that's the first pairing. Position 1 scores this many points. We then cater for position 2, and we say position 2 scores this many points. And I'm fixing each of these cell references as we go down. So if we continue down, we just choose each subsequent cell, and we end up with this. So looking back through the formula, the very first thing in the formula again is the cell that we're checking. The next thing we say is, if E3 equals 1, we show this. If E3 equals 2, we show this. If E3 equals 3, we show this. All the way down to position 10. Now again, I'm going to press enter and copy this down. And just like for the choose function, we get errors for positions 11 onwards. But the switch actually has a catch-all feature to prevent this kind of thing happening. And it goes like this. So you've got all your pairings, and then as a very final thing, if you put something like a dash inside quotes, or maybe just quote quote, or maybe some sort of text or a number that you want to put in there, this is like the catch-all that will be shown for anything that's not catered for beforehand. So with this done, we press enter, we recopy this down, and you can now see that all of those drivers that scored 11th position or below now show a dash rather than an error. So that's a quick comparison between the old choose function, which has been around for years, and the new switch function. And I think that's a good place to finish this video. So I hope this video has answered your questions about if functions. If you like the video, don't forget to click the thumbs up. If you want to subscribe, then you'll get notified of any other videos similar to this one that get published. See you for the next one.